Thank you so much, Jeffrey. This is great. So welcome, everybody, to this Develop track. We have a great panel here for you today, and we're going to talk about building the AR cloud. The AR cloud, as we've read, has been described by Ori Imbar as the single most important software infrastructure in computing, far more valuable than Facebook's social graph or Google's PageRank index, a future behemoth of computing. But before that can happen, it needs to be built. And so we're here today to talk to some of the groundbreaking founders and participants in building the AR cloud. And we're going to talk about some of the different ideas, different approaches, and exactly what the nuts and bolts are of this endeavor. So if we could kick it off, actually, if Jan-Erik, if you could introduce yourself and tell us a little bit more about what you're doing, that would be great.
Yes, I'm Jan-Erik Vinje from Norway, where I work in Norkart AS. That's a geospatial software solution company. Last year we did a little prototype on geospatial AR, where we geo-aligned on a consumer device for the first time. And we ran into some issues, and that led us towards the open AR cloud. So that's what motivated me in February after reading about Ori Imbar's AR cloud concept, that we should do open AR cloud. We should build a community to solve this hard technical problem together, and also solve the societal part of it, so that we create a good open AR cloud where privacy issues are tackled and handled in a proper way.
Awesome.
Cool. Hi, everybody. My name is Ed Miller. I'm from a company called Scape Technologies. And although some of you might not know about us, there are about 30 of us computer vision engineers working outside of our office in London. So we're quietly working away. And what we want to do is we want to return your precise location and orientation more robustly and more accurately across an arbitrarily large amount of space as possible. So we don't want to localize your position within a room or a building or a street. We want to determine where you are with precise centimeter accuracy across an entire city or larger. That's what we do at Scape Technologies.
Hello, yeah. So my name is Anil Cheriyadat. I'm the CEO and founder of Sturfee. So as Emily was pointing, AR cloud. So we don't call it AR cloud. We call it VPS, Visual Positioning Service. So it's a very simple yet powerful service that would enable, as Ed just mentioned, cameras to locate where they are looking, not much relying on the GPS, but by matching what is around the camera. So if you're looking outside in the street, you hold your camera up and look around, it can precisely locate where you are. And so that is the VPS service, and we are a team of 13 people working from Milpitas. We are in the business for the last 3 years, and there's a lot of interesting stuff that can be accomplished by the service.
Nice, hi. So I'm Dave Lorenzini, and we are UAR.io in Portland, Oregon. I've got about 15 people who've been working the same for about 3.5 years, building a platform, a real end-to-end platform that allows people to move their content and the internet itself off screens and out into the world around you. So if you're a developer, you can publish your stuff you're doing today with Unity into a world where it belongs, locked to locations, and that's shared and viewable and synchronized between all of the iPhone users or Android users or future HMDs and smart glass folks. But we make it easy to publish interactive experiences where it's going to do the most good, where the people are out in the world. We'll talk a little bit more about that later.
Great. So we have also a lot of other companies that are not on the panel today that we've been hearing about as well, thinking about Google, Apple, Blue Vision, 60. of course, then we have the OpenAR Cloud, Phantasmo. There's a lot of people approaching these questions from different perspectives. And, but one thing that has come up in recent publishing literature by Matt Meisniks was this sort of definition of the AR cloud being thought of as a machine-readable, one-to-one scale model of the real world. And so I'd like to hear how much that encompasses your vision of the AR cloud. Is that true? Is that what we're building, what we're trying to achieve? Is it a new map? Is it a coordinate system? What are we trying to, what is the thing we're trying to solve for?
Yeah, the fundamental building blocks. That is, I'm quite in agreement with Matt on having this one-to-one, real-time updated map, but it will not be just one map. It could be any number of maps. And you have this real-time map, and I've seen like everybody is using some sort of vision approach. We have like 3 different vision approaches, maybe 4 different vision approaches, just sitting here. But in principle, it's very similar. You observe with the device, and you send this observation up to the cloud, and the cloud can return to you some sort of 3-dimensional orientation plus 3 more degrees of freedom that shows the pose of the device. And with that, you can have real multiplayer experiences, and you can have real persistence of objects, and we can like have agreed upon ways to place virtual objects in the world, and that's the fundamental thing. And then you have the technical foundation for a shared programmable space. Mm-hmm. That basically is that's the kind of AR that I've always been envisioning. AR that does not do that is basically just a fancy toy, and you don't get much more beyond the gimmicks. So forever I've been thinking you have to have this synchronization with the real world, and that's the core technical underpinning that will enable AR to become something really useful and economically viable.
Cool. Well, we're all here because of the term AR cloud has been taking off, and everyone uses this to understand some part of what we're all doing. But I think it's an incredibly misunderstood term that doesn't really go into detail about what we're actually trying to achieve here. And I think the reason why Ori says that this is the next big thing is not because of a map or a way to localize a device or any particular piece. It's about the fact that this is one step closer to machines being able to understand our world around us. Right? AR is about bringing the graphical user interface into our world, but it's also, importantly, about bringing our world into computer understanding. It's that machine-human understanding which is the piece of the puzzle which currently doesn't exist, and that's not just location. Location is having like one tiny little core piece of that. We've talked in the past about, I think it should be differentiated between AR-specific sections, AR cloud specifics versus just general machine perception specifics. So on the machine perception side, you've got things like, where am I? What's your location? What's the world structured like? What's the geometry like? What's the semantics? What are the objects in the room that you can see around you? And what's the networking that you can use to communicate between devices? That's all part of machine perception. That's all about machines being able to understand the world around them that's as applicable to robotics, self-driving cars, AR as much as anything else. AR-specific stuff, talking about, right, there's a content repository, there's a database that says there are these objects at these particular locations. That's a separate part of the same thing that we're calling all this AR cloud at the moment. And hopefully over the next few years, there will be a little bit more understanding as to what pieces of the puzzle each company are focusing on, but ultimately the consumer doesn't care. The consumer doesn't care about how accurately you can determine your location. If they're an AR user, they just want to know that the Pikachu is exactly where it should be. That's it.
Great.
Yeah, I'll add on to the same conversation. So the challenge, as Ed was pointing here, is so if you want to understand the world, you have to measure the world. You have to capture and measure the world, so that the device, your camera, can look at the scene and say, "Hey, I'm looking at the scene. I'm matching this scene against something in my AR cloud or some service or some database and saying that, hey, I'm exactly looking at this place. And this data you're holding in your cloud or database, which is going to call as AR cloud or VPS, whatever it is, this data has to be a precise measurement of the world or a precise copy of the world. That's what the discussion is like. It should be a 1:1 ratio. If I'm standing here from this point to that point, it is 30 meters. The data inside the database should have the same 1:1 kind of a measurement. So now the challenge is like, how do you measure this? How do you capture the world? You're not talking about doing it in a corner of a street or some part of the city. You're talking about doing it at a planet scale, country scale. So machines can operate freely around you, and the cameras can provide you the kind of abilities, you kind of superpower kind of an abilities, not only for just playing the games, the feeling that you have the information in your in your fingertips. Everywhere you have information. So this is the kind of things. But again, the biggest challenge which all of us are trying to solve is how do you capture this world level data so that machines, when they see the world, they can quickly match against it and say that I am looking at this exact street, maybe I'm looking at the exact 49th floor of this building, or maybe I'm looking at the exact entrance of this particular business location. So these are the kind of challenges we are trying to solve. It will be very interesting to see how all these companies are going to evolve and solve this puzzle, actually.
Yeah, the challenge thing is what hits me. I've mapped the world a few times with things like Keyhole that became Google Earth, and when I needed data, I could go out and just buy all the satellite imagery I needed and get the streets. My biggest problem was making the streets line up with the pictures. And now, again, we've touched on a real-time map of the world. There's a lot of ideals for what this environment would enable, but getting environments from street view level stuff to going inside, I need to know and recognize which one of 1,000 hotel rooms I'm in at the MGM Grand just by turning on my phone in order to have someone drag some holographic piñata that's going to give me birthday gifts from Pepsi or something, right? So by putting content into the world exactly where it belongs, you need to understand these environments. And it's really more a matter at this point in 2018 of creative solutions to build this airplane while it's in flight and to make this stuff work before we have the map that we're all knowing that we're going to go after, and making the commercial efforts jive with the mapping efforts, jive with the portal efforts and the open efforts, so you have things that are going to contribute to this global map that range from all over the map, from very high-end commercial survey and mapping efforts, all the way to putting a rare Pokemon in the middle of this room, and 200 people will show up waving their phones around, and that, in effect, can give you a map of this space from handheld consumer devices. So it's an incredible challenge, but the payoff is the ability to enable all this stuff in the world around us. So we're all going.
Thanks. And Dave, to sort of build on that a little bit, there's four difficult things that UAR is outlining as the things that every AR cloud platform needs to be able to do. And one is to localize devices. Two is to position these AR objects. Three is to synchronize users and actions. And four is to visualize remote scenes and spaces. So I'm curious to what degree we feel like those are the critical pieces to this, and maybe you can talk a little bit more about what this is going to enable. What will that produce if we're able to accomplish those four things?
Yeah. So basically, figuring out what you're looking at, putting the right stuff in that place. Hard part starts when you take tens, thousands, hundreds of thousands, millions of users all seeing the same virtual objects. And as we put a target up there, if everyone's shooting baskets at it, seeing all the other actions and interactions and viewers, not only of local people in that space, but a really fun part of this that's coming is the ability for a remote person to interact with people who are in a place at a distance. Today we call that things like AR if you're there, and VR if you're looking at it from afar. But it's really the same concept of enabling this view, interaction, and presence at a distance. So some of the more exciting and interesting stuff. And if I was going to show this space to someone who wasn't here, I could put a 360 camera in the middle of the room and start adding AR objects into that view. That's one way to do it. Or again, we live in a world where if you want to deal with this kind of technology, you're taking Unity or Unreal and you're creating models of these spaces and then going that way with the game engines. But it's all trying to create these systems that enable these kind of transcendent virtual experiences that blend the real world with the digital objects.
Great. And so Anil, Sturfee has actually already established its service in a number of US cities, and I believe you're trying to roll out to, is it 10 cities by the end of the year? And so I'm really curious about this because on the one hand, we're talking about creating this, this coordinate system, this AR cloud that will blanket the planet. The planet is the platform, but yet we've already got someone who's deployed this in a city, and maybe Ed can talk about this too. Talk to us about that. Talk to us about what it's actually like now deploying a service in a city.
So we have this service, which I mentioned, VPS, Visual Positioning Service. You can imagine it as more like an intelligent GPS. So we have this VPS service available in 10 cities, San Francisco, Los Angeles, New York, Miami, Boston. There are 10 cities it's available. It can be accessed through an SDK. You can download it from our website, and right now you can experiment what kind of applications you can want to develop. And how we were able to do this in 10 cities, again, as you just heard now, the biggest challenge here is how to capture this data, because we are talking about making a machine, like a camera, look at the scene, and within a fraction of a second, making the camera aware that you are looking at this particular location of this particular street corner. So that's without relying on the GPS, right? So that means you need to have a copy of this world, this 1:1 copy of this world. And this is how we differ from some of the solutions or approaches that I've taken in the industry or the market. So we look at from the top down. So there are two ways of doing it. From the bottom up, as Ed and others can explain much detail. So one is bottom up, that is you collect all these pictures of the place, and from that pictures you generate some kind of signatures or in 3D information. So when the camera takes a picture, you compare that signature with your pictures you have taken. The other way is, so this way is, you have to map the city, go around and take pictures of all these places, and there's some challenge in scaling that. The other way is looking from the top. So there are satellite imageries. So satellite imageries, as you have seen in Google Earth and like Keyhole, it can provide a continuous coverage of the entire country, entire planet. And it is the kind of 1:1 kind of a measurement. Every pixel on the satellite imagery is exactly the measurement you want to have, right? But how do you use the satellite imagery to give this camera the ability? Because satellite images are from the top down. The camera is looking from the ground. So you stand on the corner of a street and you look at a scene. How can the camera connect that scene with the satellite imagery? So that is what we have solved. So we have solved it using the machine learning process, where a camera can understand where it is looking by comparing it with the satellite imagery, which is taken of the same location, but from a different view. So that is the interesting challenge we have solved. And since we have solved that, we are able to scale this very quickly. So that's why we are able to put this service out in 10 cities. And very interestingly, people are trying out different ways. Like even like you don't have to go to the AR part, that kind of experience. There are very simple challenges where people are trying to solve. You step out onto the street, the first thing you are trying to figure out is, where am I? You have your smartphone, you're figuring out where I'm oriented, which street should I go, right? So the one solution which you can use is you take your phone and simply scan. The phone will look at the scene and precisely tell you, you are standing at this street corner, you're looking at here, and this is the direction you want to take. It can be applied for DoorDash people. Next time when you try to get your Uber car, you can, instead of putting the pin on the map, you can hold your phone and do like this. So any kind of location-based application, this service becomes a very, very paramount or critical factor. So as we have launched this service, and there are different companies starting from phone manufacturers to gaming companies who are experimenting our service. And being able to put the service out early, we are able to learn what are the challenges in using it, what are the limitations, what are the inaccuracies. Yeah, thanks.
That's great. Actually, Edward, if you could build on that a little bit, because from what I understand, this machine perception cloud is actually, we hear the word, this sort of semantic understanding of our space, and so it's not just recognizing where I am, but what am I looking at, and having an understanding of this actual object. Maybe you could build on that, because I know you've also been working in that area with Scape.
Sure. So I guess the thing to realize is that all of us have got similar end goals. It's all about building this digital twin of the world, this world on a CPU chip. You know, that's ultimately where we're all going. The interesting things are where the choices of what we've made in terms of our engineering decisions differ. And they differ to prioritize slightly different use cases. But ultimately, building the world on a chip is all our end use cases. I talked about the different layers of this machine perception. We've got location, geometry, semantics, and networking. Our goal at Scape Technologies is to be the most robust, arbitrarily scalable, so infinitely scalable platform to determine your location, whether it's sunny or snowy or rainy, which is in itself a tricky component. But also, once you understand that location, that's just the very first step. You know, then you need to build upwards. So we do need to provide geometry, we do need to build semantics. You talk about semantics. So understanding what you're looking at, whether you're looking at the road or the pavement. Now, they are very similar geometries, but if you can understand the difference between road and sidewalk, essentially, that has a particularly profound effect if you're a self-driving car, for example. Every single pixel within our own pipeline at Scape Technologies has a semantic class associated with it. So that means every single pixel has got a label saying, this is a postbox, this is a pavement, this is a sidewalk, this is a door, this is a window. And right now, we use that information to determine how can we build the best, most accurate map as possible. So that means we occlude or omit things like people, for example, or cars, or dynamic objects, or things that change, things that limit our ability to build the best map possible in order to determine your location as most accurately as possible. But there will be a point in the future where you choose to offer that semantic information up to the user in real time. So, for example, if you're building an AR application for entertainment, you might want to make it so that if you point out to sea, you will see, sea-based Pokemon, for example. But there, you can have some more serious roles if you're using AR in construction or any of these other utilities. So this type of understanding of the world is coming, but you've got to do it one step at a time. So our priority at the moment has just been to make everything as firm a foundation as possible to build all the other layers on top of what we have.
Yeah, that was an awesome technical pitch, and I couldn't agree more. It's the semantic understanding is what is really going to make a difference. In Norkart we have much more. We don't have like, I don't know how many PhDs from Oxford you're running.
We've hoovered up quite a lot. Yeah.
Quite a lot. We have 2 master students, and they get some help from a professor, and I assist them. But we have this semantic approach, very basic. We're just doing something like we're evaluating different neural nets that could detect objects, and not only object, but what type of object. So you have like a semantic understanding, very crudely. So you have more or less a bounding box here and a bounding box there, and this bounding box says like it's a light pole, and this bounding box says that it's a trash bin, and this is a bench, and that's we call this kind of observation, when you have an AR context, you're able to know the distance and the geometrical relations between these semantic observations, and it's very sparse. And I think that's a good start for a basic location service, where you want to send what we call a semantic constellation. We send these observations as a constellation to the cloud, and it has prior observations. So we do bottom up, just like you do, and we will do that eventually. We haven't actually gotten this service up and running yet, but that's what we are envisioning. and we can return an estimate of your 3D pose plus your 3D location plus your orientation. So you have a geographical three-dimensional pose in the world. So it'll be exciting to see what we could do. I would really like to have a pixel-by-pixel semantic map. Like do you do that real time?
Not in real time.
Not in real time. You can do that eventually. So at least 15 years from now, it will obviously be real time, pixel by pixel, but not quite yet. So I think maybe our approach is quite workable at this stage, but we're a small team. That is what that's part of what inspired me to think that we can try to build this little rocket, and maybe we can try to launch it, and we'll go like 3,000 feet up in the air, and it will fall down and crash. But if we share our experience, we do our research open, and we put it on GitHub, and other people can look at it, and we can explain, oh, we did this and we did that. Then we can look at what other people do. If you share some of your PhD theses online, as a lot of the AI research is open, and it's tremendous. It's accelerating. It's really creating like a big bang of AI, because everyone is sharing their results, and everybody can look at what the other people are doing. And if that happens in AR, then the power to the people, you know, it's not locked up. It's like Elon Musk is going, how do you avoid a bad AI outcome? He believes in spreading the knowledge of AI instead of letting some sort of concentrated power do the leads. So yeah.
Yeah, I think just to add on that, the speed at which these algorithms are progressing in academia is literally astonishing. So we do make sure that as part of our team in London, it's a core piece that we remain at the very forefront of research. This means we do actually go out there and we do publish papers, because honestly, there are two reasons. First of all, it's a practical point of view, because if you don't allow people to publish their research for an academic, this is, you know, there are kudos points. You know, you need to make sure that you offer that in order to provide a good place to be. But also, honestly, if you're not the ones leading the conversation in academia, you're already 6 months behind anyway. It's moving so quickly, and you really need to be at the forefront in order to have any kind of chance at competing.
One other thing, like this semantic thing, it's so powerful because you are able to, of course, create the best user experience ever in the world, because everything, the machine knows about every surface and what sort of object it is, and what sort of mood even like the people in the room around you are having and what they're saying. Like you could use this sort of technology to get a more complete understanding of your surroundings than any person is ever able to. And if that sort of understanding and data is concentrated inside entities that has business models that profit from manipulating user behaviors through ads, it becomes dangerous. You have something that is more powerful than any empire the world has ever seen. They have this power based on selling ads and manipulating people's behavior. So it's so extremely vital that we find ways to do this that protects people's privacy, and that people know that their privacy is not being invaded. You have this receptive field of the devices that track other people that are not using the device. So you don't have to just handle the privacy of the individual that is using the app or the device. You have to take care of the privacy of everyone in the sensor range of the device. And there's so far we don't have like the complete answer to that, and that's one of the things that I would hope people would join this open air cloud to tackle that hard question. So there's a research part of that, and it's like a policy and ethical part of it. And we need all sorts of people to join that conversation and contribute.
Yeah, I mean, to add to that point, but the idea of machines or devices having this capability to see and understand the world using cameras, so that's going to happen. Even like if all these companies we are sitting here still fail, but still the solution is going to happen. But if you think, why? Because you think about the progress. We started with this computers in a big room, right? Then we started to desktop. Then we have phones. Now, you see that you are able to move with this supercomputer in your phone. So now the next progression is this computer is going to see the things around you and assist you. So this natural progression is happening. So if you look at how the technology is progressing, this need for devices to see and understand the world, it is going to happen. That requirement is there. The market is there, actually. It is just the matter of how this solution is being, formulated and implemented and tested, and so. It's like for me, it is. I'm quite excited to see this technology path going. Coming from smartphone, and people started using cameras more. Look at Instagram. A lot of people are there's industry around just using camera technology, right? So now the next wave of industry is how cameras can assist you. It could be starting from stepping out of the street and waving your camera and helping you to locate exactly where you are looking, taking you to different places, or it could be the machines, the robots, the drones. So any machine, any device would require this, and this notion of AR, it's not going to limit with AR. We think that it's going to be an augmented reality. It's just not an augmented reality. It's just understanding the world and allowing and enabling the machines to assist you in doing better and easier things, actually.
I am. Thank you. That's a great segue into one of the quotes that I found while I was researching for this panel, and it's from Nick Bonatzos at General Catalyst, and he says, AR is the future of media and entertainment. This is why companies like Snap and Facebook care so much about owning the camera experience on your phone. It's the single most important sensor on any mobile device now. And so I think that those questions about us being part of the building the AR cloud as well. We all have these smartphones in our pockets, and we'll be contributing to the building of this AR cloud. It's a really great existential question for all of us to think about. What is our role in that? And we do have some time, a few minutes for some questions from the audience. If anybody has questions, I'd like to open it up before we close. Do you have questions for the panelists? Yes, you.
So the question is, if you're building a real-time map of the world, or ideally building that, how do you make that happen? And it starts by understanding what changes. So you weight things based on their permanence. The walls here, certain walls in this convention center are fixed, certain move, so they'll get different weights, and you need to try to update different places at different frequencies to enable different experiences. For different reasons, for different people. It's literally, this is just an infrastructure, just like the infrastructure of the web enables the wealth of what we do online. This is going to underpin everything. So there's a lot of spaces get kind of interesting and static when you're above 6 feet, and you don't have people moving around or chairs moving or things like that. So you can do a lot of AR in environments with certain elevations and other things, but really it's understanding the environments and then putting the incentives in place to collect those in a way, the path of least resistance kind of way. So when you're mapping the world, the only way to do it is every way possible. And if one way is to put the rare Pokemon and have people show up, that's one way. We're doing stuff with the OpenAR Cloud Foundation and other things that are going to be under augmentedreality.org here, where we're just going to make it really easy for people to request places that they want. You might want your living room to be requested so that you could have a social experience at a distance with your friends or family. So just dropping a pin and saying, hey, I want this collected. And that might be fulfilled by a guy, a TaskRabbit with a structure sensor coming in and scanning your living room, and now that's live, it's a live space. Another way is to request a space, and if enough people request it, then it gets collected. So it's kind of a thresholding thing, or bountying a place. If you're a business owner and you want to enable fire sale Thursday at your pizza place and put your walls on fire and have people eating flaming pizzas, if you're looking at it through the phones, you could bounty it and request it and say it's worth it to me to pay $50 to have my space scan. There's a million ways to request spaces and get them done, and we're going to exploit them all to get the maps that we need. And then as a community, we're going to end up with so many different maps of the world that the best thing that I think we can do up front is hold an index, at least know who has maps of what. If someone's driven all the streets in a city or done something, in a lot of cases, the smaller companies will be failing over to bigger services, but enabling very rich experiences in certain locations. There's lots of ways it's going to take shape, and it's focusing on getting the result you're after before the infrastructure exists is the way you want to think. So a lot of things could just be dropped into this room and all of you could see it, and that wasn't scanned or mapped or anything. We use a concept at UAR called drag, drop, and lock. So I can drag and drop stuff into a location, and it's going to get it close. And I might have to look around a little bit to figure out where it is, but then once I find it, I can press and hold and lock it to this stage or to a thing. Again, you're trying to lock to both real and relative positions. So a lot of what's coming, you might just want it 10 feet in front of you at all times, or around you or something. So there's a lot of different environments to think about. And don't let the fact that this AR cloud doesn't exist keep you from putting your content out into the world, which is really what's going to start getting the experience going.
Great. Well, I believe we are done with this panel. We're out of time. I hope that this is a invitation, actually, from everybody on the panel for you to come up to them, speak with them, ask them about what they're doing, and connect, because I know that they're all really excited to be here. Did you have one more comment?
Yeah. If you want to know when we get started with this new organization that joins the effort of AR Cloud Foundation and OpenAR Cloud, you can go to tinyurl.com/openarcloud. tinyurl.com/openarcloud. And there you can sign up, and you can also check boxes if there are particular things that you would like to contribute to. There are like a host of interesting topics. So I hope I will see many of you sign up for that.
Thank you, everybody. Thanks so much.